We're looking at the Do Button app from IFTTT. The Do Button app allows you to create some type of phone interaction that can publish events to the particle channel in IFTTT, which basically means you can have your phone control your robot. So I'm going to hit Add a Recipe. When I create this recipe, I'm going to go ahead and choose my particle channel, and it may require you to log into your particle channel. I've already logged in, so I'm not going to show you that part of it, but you want to log in with the account that's going to be controlling the specific device you want to create the interaction with. We'll create a recipe, and we'll say publish an event. Now, we have to choose an event name for it. I can call this title whatever I want. I'm going to call it Go, Go, Go. And I'm actually going to change the event text so that it's specifically an event that says Go, Go, Go. And the reason why is because I can subscribe to that specific event using the device firmware. I'm going to clear out the event data because it's not particularly important to me right now. But when you choose whether or not you want a public or private event, choose private event. Otherwise, it's going to publish the event to the global particle I/O event stream. Now that I've created that recipe, I can go ahead and just touch this button, and it will generate the event and a notification that the event actually successfully completed publishing. In the dashboard, we can look for the event that the Do button is going to generate. When I hit the Go, Go, Go button, eventually you'll see that the event name appears, and it was generated, and this did appear in your event stream. So we know that the device can receive the event. But how do we get the device to respond to the event? Well, to do that, we need what's called an event handler. Inside of the Build IDE, we can go back to the CodeTak Robotics library and find that the fourth example creates a handler. So we'll use this as the example library. Okay, so now that we're here inside of the handler code, you'll notice that I have all of my robotics motor code here, and there's another method that I've added to the example called handler. And this method, or this function, is going to be triggered when the Go, Go, Go event happens. Now, there's nothing that's subscribing to it yet, nor is it going to trigger the handler, but let's go ahead and put that code in now. Inside of the setup method, I can say particle.subscribe, and then the name of the event. Specifically, the name of the event that I wanted was this Go, Go, Go event. So I'll type it in exactly as it appears. The second parameter is the name of the handler function that is going to run when the Go, Go, Go event occurs. Lastly, because we set this to be a private event, we also want to make sure that your particle photon knows that it's subscribing to a private event. So we add a parameter that says my devices, and therefore it will only listen to events that are Go, Go, Go that are generated from either your account or any of your other devices on that account, rather than listening to events on the global event stream. Once I flash that, it should be able to respond to the event. Now, if we look at the handler itself, the handler is a little bit complex. So it's okay to copy the function header if you want to create a second handler, and all you have to do is change the name. But there is a lot of data that goes into the event handler. Notice that there's a variable called event, and then another variable called data, and these are what are called char pointers. Now that's something that's unique to C++, and you don't have to worry about dealing with it, and this video is not going to cover it. But effectively, you can use one handler that can respond to multiple types of events, and this function will receive the event name as data, as well as any additional data that you attach to the event in that event data field back when we did our IFTTT Do button recipe. But for now, all we see is that the handler is simply just going to make the robot go forward, delay 1 second, and then stop. And that's enough to get our robot to respond to the Go, Go, Go event.